A fairly simple Visinode has been added to our project. It contains a function called wd4Part1bHD. With respect to the top left corner, this function compares its own position within its parent Visinode to a value passed to it. If the value falls outside its perimeter, the function returns the string content, high or low. If it falls within its perimeter, the function returns box. Just after the color contents are computed inside the sensor function, we will call the wd4Monitor function to process the value. If all is done correctly, the level monitor should tell us if the red intensity falls outside high, low, or inside its perimeter, the box. The level monitor doesn't care about the horizontal position of itself. The only thing that matters here is the vertical level. Nothing should be printed unless the color content value is inside the wd4Monitor box. Once the level monitor and the color sensor are interacting correctly, we will clone the red level monitor twice and paint each border to match the color of their respective bar. Every new level monitor cloned needs to be individualized. This can simply be done by adding a single letter to represent its color. We will now have to allow the color sensor to call every new wd4 monitor individually and use the correct color labels for each. Here, we take a significant step towards our end goal. The conditions are set so that each color level must be inside its respective wd4 monitor box for the watchdog to log a security breach.
Oops, forgot to color the borders of the level monitors.
The vprint function is provided by Visifront, but the application will have to stand alone and operate independent of Visifront. Therefore, an extra log box needs to be added to our project somewhere within the workspace.
Another blunder. Only the red wd4 monitor is called. That must be rectified.
The spinning color calibration is just a video like any other video. We have seen how it works. So let's cut the story short and bring in a different video. Since the erase command erases the Visinode including all its children, we need to rescue our enhanced color sensor, so we don't delete it along with the calibration video. In other words, it needs to be pulled out of the video frame before the frame is deleted. Then we can drag another movie into Visifront and see if we can extract any sense from it. we should adjust the color sensor to capture the area of interest exclusively. For serious applications, there are many technical limitations to consider. These issues are often computable, and when not, one may apply the trial and error method like we do here, towards an acceptable solution. Here is a bigger and better recording. Next, the video will be replaced by the USB camera attached to this computer. Same cautions are necessary to ensure the enhanced color sensor is not erased, although it is already saved on the stack and retrievable. The real world is getting ever more complex. A person may spend a lifetime on just a small portion of what is required to bring projects to fruition. We hope the visual attributes of Visinode will make individuals more effective and help entrepreneurs and communities bring projects to perhaps an equitable level prior to a major financial commitment.